Everyone, today I am going to discuss one of the topic of channel, that is called angle bisector. So angle bisector. Suppose guys, suppose dear students, these two are the lines. These two are the lines. This line is L1 equal to A1x plus B1y plus C1 equal to 0, and this line is A2x plus B2y plus C2 equal to 0. Now this is one of the angular bisector. This line is one of the angular bisector, and this line is also one of the angular bisector. Okay. Now what I am going to do is I am going to draw perpendicular from this line to both these lines. Now you know this. Suppose this is N, this is M, this is P. So Pn equal to Pm. Because perpendicular distance, they are perpendicular distance, so they are equal. Now I have to find the locus of point h comma k. Actually directly I am taking this is x comma, automatically we have to remove h by x and k by. This is locus problem like locus. So what I am going to do, I am going to write perpendicular distance. So a1x plus b1y plus c1 by a square root of a1 square plus b1 square mod a2x plus b2y plus a c2 by a square root of a2 square plus b2 square. Now if you will open, then you will get a1x plus b1y plus c1 equal to a1 square plus b1 square equal to a2x plus b2y plus a c2 by a square root of a2 square plus b2 square. This is one of the angular bisector when both these two, when both have same sign. Now a1x plus b1y plus a c1 by a square root of a1 square plus b1 square equal to minus times of a2x plus b2y plus a c2 by a square root of a2 square plus b2 square. This is second. Now we have to decide either this equation 1 is the angular bisector or equation 2 is the angular bisector. How we will decide? Now I am going to take several cases. Then we will get the idea to decide either equation number 1 is the angular bisector or equation number 2 is the angular bisector. So first I am taking bisector containing 0, 0. Bisector containing means bisector containing origin. So I am going to take first bisector containing origin in its region. Okay. So bisector containing origin in its region. So this is one line, this is other line. As usual we have L2 and L1 as usual. L1 is as usual a1x plus b1y plus c1 equal to 0. L2 equal to a2x plus b2y plus c2 equal to 0. Now suppose this is one of the angular bisector. This is one of the angular bisector. This is one of the angular bisector. This. Suppose 0, 0 is there, and h, k is lying on this line. If you want to decide, if you find the equation of the angular bisector containing 0, 0, c1, c2 must not equal to 0. Be careful. Now what I am going to tell is this h, k and 0, 0 lying on the same side of the line with respect to line L1. So I am going to apply one of the concept a1h plus b1k plus c1 into c1 should be greater than 0, and a2h plus b2k plus c2 into c2 is greater than 0. Now suppose h, k is there. H, k is lying here. Now what will happen? a1h plus b1k into c1 is less than 0, and a2h b2k plus c2 into c2 is less than 0. Why? Because with respect to these two lines, both two are lines on the opposite side. So L1 dot L2 less than 0. Now we can conclude that I am going to conclude one thing. See, C1 C2 A1H plus B1K plus C1 A2H plus B2K plus C2 is greater than equal to 0. Is greater than equal to 0. So now we can conclude that point H comma K lying on bisector containing 0 comma 0 in its region satisfying. Now A1 hex plus B1y plus C1 by square root of A1 square plus B1 square equal to A2x plus B2y plus C2 by square root of A2 square plus B2 square. Again we have A2x A1x plus B1y plus C1 by square root of A1 square plus B1 square equal to minus times of A2x plus B2y plus C2 by square root of A2 square plus B2 square. If C1 C2 is greater than 0, then equation number 1 is the angular bisector. If C1 C2 is less than 0, then equation number 2 is the angular bisector. Now again I am going to which either equation number 1 or equation number 2 will the angular bisector. So bisector containing point alpha comma beta in its region. As usual, this is one line, this is one line, and point containing alpha comma beta. This is point containing alpha comma beta, and this is the point on the line H comma K. Okay, now actually then bisector containing the point alpha comma beta in its region, then we have to decide which one will the angular bisector, either equation number 1 or equation number 2. Like here, if bisector containing 0 comma 0 in its region, then what I told you, based on the condition, if C1 C2 is greater than 0, then equation number 1 is the angular bisector. If C1 C2 is less than 0, then equation number 2 is the angular bisector. Then equation number 2 is the angular bisector. Now if bisector containing point alpha comma beta in its region, then what I am going to do is, see, this alpha comma beta must not lie in line. If it will lie on the line, then that line becomes 0. So here simple one concept is there. A1 alpha plus B1 beta into C1, A2 alpha, B2 beta plus a C2 into A1H plus B1K into C1, A2H, B2K plus a C2 should be greater than 0. Simple here, put alpha comma beta in its line. If product is 0, then equation number 1 is the angular bisector. If their product is less than 0, then equation number 2 is the angular bisector. So simply what you have to do is put point alpha comma beta in the line. Put point alpha comma beta in line. Now one more concept is there. Okay, suppose this is angle theta, this is also angle, but this will be obtuse angle. Obtuse angle. Suppose I am taking beta 1 is one of the angular bisector. Suppose a1x means equation number 1 is one of the angular bisector. Suppose equation number 1 is one of the angular bisector. Suppose equation number 1 is one of the angle. Now what we need to do is, we know the slope of this line, angular bisector is one of the lines. We know the slope of line L1. So tan theta equal to, write directly, slope of line beta minus slope of line L1 y1 plus slope of line beta into slope of line L1. If this is less than 1, then beta 1 is acute angle bisector. Suppose this slope is greater than 1, then beta 1 is obtuse angle bisector. Obtuse angle bisector. Okay, simple. See, once again I am explaining. This is line L1, this is line L1. This is one of the angular bisector, beta 1. This is one of the angular bisector. Now find the slope of, now you know the slope of this line and you know the slope of line. Now find tan theta. If tan theta is less than 1, then beta 1 is acute angle bisector. If tan theta is greater than 1, then beta 1 is obtuse angle bisector. Otherwise, we can also do like this. See. See carefully. This is one line. This is one of the line. So this is line L1 and this is line L2. Okay. This is line L1, this is line L2. Now this is one of the angular bisector. And this is one of the angular bisector. Now what I am going to do is, P of alpha comma beta is on this line. Now draw perpendicular distance. That is P1 and that is P2. Okay. Now again beta 1. You know beta 1 a1x plus b1y plus c1 by square root of a1 square plus b1 square equal to a2x plus b2y plus c2 by square root of a2 square plus b2 square. Now what is beta 2? a1x plus b1y plus c1 by square root of a1 square plus b1 square equal to minus times of a2x plus b2y plus c2 by square root of a2 square plus b2 square. Now simple. Find perpendicular distance. Simple. There is no need to worry. Simple, find perpendicular distance. If P1 is less than P2, then beta 1 is acute angle bisector. Then beta 1 is acute angle bisector. If P1 is greater than P2, then beta 1 is obtuse angle bisector. Obtuse angle bisector. Okay. So simple, yes, there is no need to. We know this is one of the angular. So simple, again I explain. This is one of the angular bisector. This line is one of the angular bisector. So beta 1 and beta 2 angular bisector is there. Now for perpendicular distance P1. So easily you can, if point is given and you have to find the distance from that point to the line, is directly use the formula. If P1 is less than P2, then beta 1 is acute angle bisector. If P1 is greater than, then beta 1 is obtuse angle bisector. Now I am going to discuss one more concepts. Suppose this is one of the angle bisector. This is one of the angle bisector. Okay. This is perpendicular. These two lines are perpendicular. Suppose this is theta 1, this is theta 1, this is theta 2. So what is theta? Theta 2 minus theta 1. Theta 2 minus, actually I am going to derive condition for origin, to lie in acute angle region. So now I am going to apply cos of theta 2 minus theta 1 less than 0. Why cos? Because sine in 0 to pi, sine is always positive, so I am going to apply cos. So this is cos theta 2 into cos theta 1 plus a sine theta 2 into sine theta 1 should be greater than 0. Now see, first time I am going to make coefficient of C1 positive. So this is minus a1x by square root of a1 square plus b1 square minus b1 by root under a2 square plus a1 square plus b1 square equal to c1 by square root of a1 square plus b1 square. Okay. Now in second time what I am going to do is I am going to make a coefficient of C1 negative for second term. So this is a2 by square root of a2 square plus b2 square into x plus b2 by a2 square plus b2 square into y by minus c2 by square root of a2 square plus b2 square. Now see, one thing I am going to do is minus a1 a2 by square root of a1 square plus b1 square into minus b1 b2 by square root of a2 square plus b2 square is greater than 0. This implies C1 is greater than 0 and C2 is less than 0. Simply see here, C1 is greater than 0 and C2. See here, if a product of these two minus a1 a2 by square root of a1 square plus b1 square into minus b1 b2 by square root of a2 square plus b2 square is greater than 0 when C1 is greater than 0 and C2 is less than 0. This implies C1 is less than 0 and C2 is greater than 0. If C1 C2 is greater than 0, then A1 A2 plus B1 B2 is greater than 0. If C1 C2 is greater than 0, then A1 A2 plus B1 B2 is less than 0. Simple. See again, if C1 is greater than 0 and C2 is less than 0. If product of C1 C2 is less than 0, then A1 into A2 plus B1 into B2 is greater than 0. If C1 C2 is less than 0, then A1 into A2 plus B1 into B2 is greater than 0. Less than 0. So this implies C1 C2 A1 A2 plus B1 B2 is greater than 0. So C1 C2 into A1 A2 plus B1 B2 is greater than 0. This implies 0, 0 lies in its obtuse region. So these are all the concepts about angular bisector, which is one of the best subtopic of a straight line. Hope I have discussed all the concepts and you are able to solve all the questions of JEE as well as advanced, or even if you're in your school exam, and these concepts may be useful for your school exam also. Again I am going to just give one again I am going to revise. I am going to give idea. Since first these two are the angular bisector, so what Pn equal to Pm. So from here we'll get two equations of a line. So now we have to decide either equation number 1 is the angular bisector or equation number 2 is the angular bisector. Suppose bisector containing 0, 0, bisector containing 0, 0. If product of C1, C2 is greater than 0, then equation number 1 is the angular bisector. Product of C1, C2 is less than, the equation number 2 is angular bisector. Now bisector containing point alpha, beta in its region. Simply put that point. If suppose this point is alpha, beta, put in that line. If their product is greater than 0, then equation number 1, otherwise equation number 2. Now again, acute and obtuse, very simple. Write one of the angular bisector, find the slope. If that is less than 1, then beta 1 is acute, otherwise obtuse. Now you can also do by distance. If P1, P2 is less than 0, then beta 1. Now condition for origin to line acute angle region, simply if C1, C2 is less than 0, then A1, A2 plus B1, B2 is greater than 0. C1, C2 is greater than A1, A2 plus B1, B2 is 0. If C1, C2, A1, A2 plus B1, B2 is greater than 0, 0 lies in its obtuse region. So these all are the concepts. So thanks everyone for watching.